Hello and welcome to Hackers Academy Hacking for Beginners course. My name is Tariq and I'm going to be your instructor for this course. This is the prerequisite course to all other trainings at Hackers Academy. Once you understand the concepts and the fundamentals in this course, you're going to be able to move comfortably throughout the other courses and throughout the other trainings at Hackers Academy. You're probably here because you want to learn hacking, but you don't know where to start, you don't know where to begin. There's so much conflicting information out there on what to do and how to begin and what to be experimenting with and what to be reading and so on. So I don't blame you if you're confused, and I also don't blame you if you want to become a hacker. Because our world has been made much better by some brilliant hackers. People like Jobs and Wozniak and Bill Gates, they all started as hackers. And they contributed so much to our world. Imagine if our world today didn't have a Jobs or a Gates or a Wozniak in it. If we didn't have the Apple products or the Microsoft products. These guys started as hackers. So what is a hacker? Did they start by breaking into things and causing havoc and causing damage? This is where we would like to draw a very clear distinction. Because unfortunately, because of the media and what you see in the movies, people have a negative association to the word hacker and hacking. But as a matter of fact, a hacker is simply somebody who has this ferocious curiosity that wants to understand how things work and how things operate, who likes to take things apart and tinker with them and make them better and improve on them. This is what a hacker is. This is how Jobs and Wozniak and Gates started. They just wanted to build things that are better. They wanted to build a better computer. They wanted to build a better operating system. They took what was there. They pulled it apart. They understood exactly how it works and they improved on it. In essence, this is what a hacker is. So if you're someone with this curiosity, if you're someone who wants to understand how things work, who wants to break things apart and who wants to improve upon things, if this is the attitude you're bringing into this course, then brilliant. Because this is exactly what is required for you to become an excellent hacker. And who knows, maybe you're going to be the next Jobs or the next Gates. So let's clarify exactly what do we mean by hacking. And who better to clarify this than one of the most brilliant hackers of our time? Did you know that the founder of Facebook is a hacker? These are some actual quotes that were written by him. And this is what he says. In reality, hacking just means building something quickly or testing the boundaries of what can be done. It's not about causing damage or being malicious or causing havoc. This is the misconception about hacking. He says hacking is also an inherently hands-on and active discipline. Absolutely. You cannot be learning hacking by just reading books and watching videos. Throughout this course, you're going to be experiencing firsthand some hacking tools and how does it feel to break into a remote system. And the hacker culture is also extremely open. It's open to sharing. It's open to giving. And you're going to experience this at the Hackers Academy forums. You're going to see what exactly we mean when we talk about being open. At Facebook, Mark says that we have cultivated a unique culture and management approach that we call the hacker way. They are so proud of being hackers, so proud of making the world a better place, so proud of improving on the way we communicate and in the way that we network, such that they have the hacker way at Facebook. At Hackers Academy, we also have the Hackers Academy way. At Hackers Academy, we highly encourage you to master the basics. We all heard of the saying that says, you cannot build a tall building on weak foundations. This is the foundational course. This is the course that you want to have a solid grip on. You want to be able to understand all these concepts in this course and be comfortable with everything we're talking about and explaining. Once you master these basics, then you can move on. And how do you master these basics? By practicing, practicing, and practicing. Mark said that hacking is a hands-on and active discipline. Unless you practice, you're not going to understand the full extent of the concepts that we're going to be sharing with you in this course. Just like any discipline, hacking requires practice. If you want to learn swimming, or if you want to learn driving or flying a plane, you could read 1,000,000 books on these topics, but unless you actually go and practice, you're not going to be able to swim or drive or fly. You could read 1,000,000 books and watch 1,000,000 videos on hacking, but unless you go and practice, you cannot understand the full extent of what we're talking about. Mind you, you have to do this legally always. And throughout this course, we're going to be teaching you how to set up your own lab so you can practice whenever you want, however you want. The second step of the Hackers Academy way is to share knowledge. Like Mark said, the hacker culture is extremely open. And once you understand the practicalities of what you're learning, share your knowledge. Go back to the Hackers Academy forums and answer questions. Some of your colleagues might have questions, might be stuck somewhere. Answer the questions if you know the answer. If you've read an article that you found interesting, share it. If you discovered a tool that you found interesting, share it. Be open and share your knowledge. Because the more you share, the more you learn, the more your knowledge will expand. And when you're comfortable with the concepts that you've learned, it is time to learn some more. It's time to start building on top of these foundations. The ethical hacking world is so vast. You could be specializing in so many different things. You could be specializing in network hacking, operating system hacking, wireless network hacking, web application hacking, mobile application hacking. It just doesn't end. And this is the beauty of the world of ethical hacking. There is so much to discover. But you can only do that once you've built a solid foundation, you understood the practicalities of it, and you start then expanding your knowledge. And last but not least, repeat. You practice, spread and share the knowledge, and then learn some more. And this is how you become an exceptional hacker. So where do I begin? This is the biggest question that you probably are asking yourself right now. And this is why you're here. This is why you're watching this video. Before I tell you where to begin, let me address some of the biggest misconceptions that are out there. You ask this question to 10 people and you would have 10 different answers, each more confusing than the other. Unfortunately, there's a lot of information out there that creates more confusion than clarity. And one of the most confusing answers is that for you to begin to learn hacking, you have to learn programming and scripting and this language and that language. The truth of the matter is, if you're just beginning, you've never done any kind of hacking before, you're an absolute beginner and you want to begin somewhere, programming and scripting can wait. Now, let me be very clear on this, because I know some people are going to come back to me and they're going to be so upset about this, saying, how can you say that? How can you become a hacker and not know programming and scripting? That's not what I'm saying. If you think that Mark created Facebook without knowing how to program, you would be very wrong. He's an exceptional programmer, and this is why he's an exceptional hacker. All I'm saying is for you to begin now, programming and scripting can wait. Later on, you absolutely, definitely must learn how to program and how to script. Without it, you cannot be a great hacker. But for now, to begin, you do not need that. You're going to see that by the end of this course, you'll break into a remote system without writing a single line of code and without reading a single line of code. Once you have the foundations, once you understand all this, then later on, go knock yourself out. Learn as many programming languages as you want and as many scripting languages as you want. But for now, there's no need to put off learning hacking and go spend 2, 3, or 4 months trying to learn a programming language. Then you'll have somebody who says, you need to learn how to use these tools and those tools and 100 other tools. As somebody who's new to the world of ethical hacking, you might be thinking that learning as many tools as you can is the way forward. Unfortunately, if you do not understand how these tools work or what do they do and what are they based on, you might be ending up causing more damage. And there's a very good chance that you're not going to get the result that you want out of these tools. You need to understand how tools work and how you can tinker it and sometimes even modify it so you can get what you want out of it. Luckily for us though, as you progress throughout this course, you're going to find out that most of the hacking tools fall under a very limited number of categories. So for example, you are going to discover that some tools fall under the category of port scanning, vulnerability scanning, online password attacks, offline password cracking, and so on. There might be dozens of tools under each category, but the important thing to get out of this is that you understand exactly what each category means. So when we're talking about port scanning, for example, what is port scanning and how does it work? Then you can move on to picking and choosing the tool that you prefer over the other tools. By the way, if you don't know what port scanning is, don't worry, you're going to be discovering this later on. Then you'll have some people that say, you cannot become a hacker unless you learn this operating system or that operating system. If you don't know Linux, you're not a hacker. If you don't know Unix, you're not a hacker. Well, Again, guys, remember here we're talking about beginning, where to begin. This is the first step into the world of ethical hacking. And I want to keep it as simplified as possible for you. Yes, later on you definitely must learn Linux and Unix. If you're taking this as a step into a career of ethical hacking, there's a very good chance that later on when you're doing security assessments, you are going to come across targets that are Linux and Unix based. And if you don't know your way around these operating systems, even if you break into that system, your security assessment will come to a stop and you wouldn't be able to progress any further if you're not comfortable with these operating systems. For now though, we want to keep things simple. So from your Windows machine, you're going to be doing everything in this course. You're going to be installing all the tools and breaking into a remote system without having the need to learn any Linux commands. By the way, the target that we have set up for you is a Linux box, so you are going to be compromising a Linux machine. We'll be teaching you very few commands that you're going to be needing, but that's about it. If you want to explore Linux later on, we have a complete course for you. You'll also have some opinionated people that say, you have to read these books and those books, and without these books you cannot even begin to learn hacking. I admit, very proudly, that I am a bookworm. I love reading and consuming books. When I was doing my master's thesis, I probably read around 25 to 30 books in the span of 3 months, and I still consume books ferociously. I love to read. Having said that, remember that we said hacking is a hands-on and active discipline. And what we aim to do with this course is to get you diving into the practice exercises as soon as possible. Reading books is all good and well, but unless you practice, there is no moving forward. Then you'll have some groups that will say, for you to become a hacker, you have to fight authority and fight the mainstream. I'm not going to dwell too much on this. If this is why you're here, you're in the wrong place. We at Hackers Academy do not advocate this. As a matter of fact, we strongly oppose this. You're watching this video because you're probably a student at school or university and you're wanting to expand your knowledge, or you're a professional with a job who's looking to expand his skill set. Either way, fighting authority and fighting the mainstream is going to get you in trouble and is unethical. At Hackers Academy, we aim to be the best ethical hackers that we can be. So, having said all that, how do you approach this course? You'll notice that this course is divided into easy to digest bite sizes, small easy to follow sections. Make sure you understand every section before you move on, because the new sections build up on the previous ones. And unless you fully and completely understand the previous sections, you might find it difficult moving forward. To help you fully understand these sections, we've included missions or practical exercises at the end of every section. Make sure you complete these missions. Once you complete them, record your success. Take notes, take screenshots, write a small report. Whatever you do, make sure that you record your success, because there's a very valuable prize waiting for you. I'm going to give you a small hint on what it is. We at Hackers Academy believe in rewarding excellent students that work hard. We do not believe that an excellent student who excelled at a course should be paying the same amount for the next course as the average student. So does that give you a small idea of what to expect? Good. So make sure you record your success. Send it to us by the end of every section or by the end of the course. We're going to review it and go over it. And based on how well you performed, you are going to be getting a valuable prize moving into the next course. Now, I know some of you talking about missions and exercises are a little bit concerned, thinking, what if I got stuck? Here's what you do if you get stuck. Replay the section video at least 2 to 3 times. There are some times when the core concept of the video would be hanging on a small sentence or a small paragraph that you might have missed for one reason or another. Maybe I'm talking too fast, maybe it's my accent, whatever it is. If you missed it, double check, make sure that you rewind the video, play it a couple of times, just to make sure that you went through the whole material. If that does not help, do a bit of online search. Start getting used to finding answers on your own. Be curious, do some research, look around, ask some questions. If that does not help, if you still don't find an answer, come and ask us on the Hackers Academy forum. It is one of the friendliest forums out there. All we ask for you to do is that when you ask your question, make it clear that you've done your homework. If you got stuck, do not give up in 2 seconds and jump on the forum and ask the question. Show us that you've done a bit of research, that you've done a little bit of homework. In your question, tell us that you've looked into this, you've looked into that, and that still doesn't help. So now you're on the Hackers Academy forum asking your question, and we'd be more than happy to answer it. If you still do not get an answer on the forum, which is very highly unlikely, drop your teacher an email. For this course, I'm your instructor, obviously. So drop me an email and I would be more than happy to answer. In other courses, you might have one or more than one teacher. Send them an email and I assure you they will be more than happy to get back to you. So here's what we're going to be learning in this course. First and foremost, we'll be talking about what the internet is and how does it work. It might sound trivial to you now, but believe me, there's more to it than what you think. Then we're going to be talking about internet protocols, what they are, how they work, and we move into services and ports. By the way, if all of this sounds Greek to you now and you don't understand what this is, don't worry. I do not expect you to know what this is. As a matter of fact, if you know what all this is, you probably shouldn't be taking this course and you can move on to the more advanced courses. Then we'll move into the 4 basic elements that you need to hack into any remote system. We'll dissect these elements, we'll talk about what they are and how you can get each and every one of them so you can execute a successful hack. Then we'll roll our sleeves and get down and dirty into packets. You are going to see how packets travel from your machine to the remote machine and dissect them and look into each and every packet. Now we're going to be talking about other common protocols that we see on the internet and how we can use them to our advantage. The following section is the one where we get our hands on our first hacking tool. We're going to be doing some port scanning, then moving to another hacking tool, doing a vulnerability scan, finding out the vulnerabilities that we're going to exploit, and last but not least, we're going to be taking advantage of these vulnerabilities, exploiting them, and gaining full remote access over our target system. So without any further delay, let's get started. It goes without saying that for you to be able to hack computers remotely over the internet, you need to have a good understanding of what the internet is and how does it work. A lot of people think that they know what the internet is, and if you go and ask anybody, somebody of your friends, your parents, your siblings, do you know what the internet is? Chances are they're gonna laugh back at you and they're gonna go, yeah, of course we know what the internet is. So, at the risk of sounding a little bit silly, I'm gonna ask you this. Do you know what the internet is? And how does it work? This is what this section is about. It's about understanding what the components of the internet are. So let's start by defining what the internet is. To put very simply, it's a global network of connected computers. So it quite literally is a whole bunch of computers all around the world that are connected to each other. Once we simplify this concept of what the internet is, anything attached to it, such as the concept of how hacking works, becomes simplified as well. This is how you start demystifying hacking. For a lot of people, hacking is sort of like this quote-unquote black art or mysterious magic. They don't know how it works and how does it happen. But once you understand that it's a big global network of computers, you start to understand that hacking is simply me accessing information on another computer elsewhere on the planet. You might be wondering, what do you mean by connected computers? Here's an article from The Guardian in 2013, and it says that damaged undersea internet cable causes widespread service disruption. Off the coast of Egypt, there was some damage in undersea internet cables, and this caused service disruption in some countries. So the internet is quite literally a whole bunch of cables, or at least part of it, is a whole bunch of big, massive undersea cables connecting continents and countries together. Here's another article, and it says that the US Navy was worried that Russia might be planning to cut the undersea cables that carry 95% of internet traffic. So internet is no longer this mystical big cloud that nobody knows where it is. Because a lot of people, when we're talking about the internet, they imagine that it's this cloud that's sitting somewhere and there's this whole bunch of data on it. But as a matter of fact, it's just this whole bunch of computers connected by cables, undersea cables, satellite, radio signals, so on and so forth. So when it comes to hacking remotely, when it comes to hacking a system over the internet or a computer over the internet, all what you're doing is you're trying to access information on that computer that is sitting remotely somewhere else. You're going through an undersea cable, you're going through a satellite, it really doesn't matter. If we want to think of it on a smaller scale, imagine that you are in your house and there are 3 or 4 different computers connected to your house router. This is a mini version of the internet. These computers that are in your house connected to the router here resembles the internet, and you can access information from one computer to another. This is what hacking basically is. It's as simple as that. Now, for hacking to happen, for you to be able to hack a system remotely, you need 4 main components. The first thing you need is an IP address. And don't worry if you don't know what this is, we're going to be explaining all of that. So the first thing you want is the IP address of the system you want to break into. 2, you want a running exposed service on that IP address or on that machine. 3, you want a vulnerability in the service that you can take advantage so that 4, you can exploit this vulnerability and gain remote control over the machine. So what's an IP address or an Internet Protocol address? We just said that the Internet is a big global network of connected computers. These computers can be connected through cables, satellites, radio, etc. Now for these computers to talk to each other, they each require a unique address. If somebody wants to send you mail, they would need certain criteria such as your name, your street address, your city, your postcode, and so on. And the same goes for computers who are on any network. For any computer on a network to talk to another computer on a network, it would need an IP address. And this of course applies to the internet because the internet, like we said, is this huge, massive network. So put simply, an IP address is a unique address for every computer on a network that wants to talk to another computer. And they have a specific form. The form is number.number.number.number. And the number could be anything from 1 to 255. Let's take the example of these 2 computers on the network. On the left-hand side, you have a computer with the IP address of 192.168.1.1. And on the right-hand side, you have another computer with the address of 192.168.1.112. These are the IP addresses that are associated to these 2 different computers. And these are the IP addresses that these computers use when they want to communicate to each other. So if, for example, the computer on the left-hand side wants to talk to the computer on the right-hand side, it will be sending its traffic or its data to the address of 192.168.1.112 and the other way around. So how do I know what my IP address is? Let's do this exercise together. On your Windows machine, click on the Windows symbol on the bottom left corner and type CMD. This is shortcut for command prompt. The command prompt is a small piece of software that allows you to interact directly with the operating system. So instead of using the graphical Windows interface, you can type commands here that Windows will interpret and will give you the output directly. The command we're gonna do is ipconfig. This is the command that displays what IP address our machine has. And as you can see here, my IP right now is 192.168.237.132. Keep in mind that if you're following on this exercise, you might have a different IP address than mine. And if you do this exercise on another day, you might get another different IP address because these IP addresses could often change. Right, so now I know what my IP address is, but what if I'm targeting a system on the internet and I want to know what its IP address is? How do I know that? The easiest way to do this is to use the ping utility. Ping is a small piece of software that sends packets to a remote system and waits for a response. It's a diagnostic tool that is mostly used to check if another system is alive or not, or is responding or not. So what we're doing here is we're typing ping google.com, assuming that, for example, we're targeting Google. Obviously we're not, but just for the sake of this exercise. So we type ping google.com and we see a reply coming from the IP address of Google. So now we know that in my country, Google's IP address is 94.201.252.25. So in theory, this means that if I now open my browser and I copy and paste the IP address in my browser, I should be able to access Google's page. Let's see if that works. Here we go. So as you can see, I can access now google.ae, which is the Google page for my current country of residence. Here's your first mission. Identify your own IP address. Like I did in the exercise using the ipconfig command, identify and note down what your IP address is. Then, identify the IP address of Google in your country. I am being redirected to google.ae, which might be different than the IP address of google.com or google.fr, and so on and so forth. And remember, record your success. Record down the steps you made, take screenshots, write down the answers, because at the end of the course, you're going to be submitting this to us to get a very valuable prize. So now you know what the Internet Protocol or the IP address is. To review very quickly, it's a unique address for every computer on a network. And because the Internet is this huge global network, every computer on the Internet will have its own IP address. Now, there are a couple issues with this. If you look at this picture of a Google data center, you'd see a whole bunch of computers. All these closet-looking things that you can see in this picture, these are racks of computers stacked on top of other computers, stacked on top of other computers. There are hundreds, if not thousands, of computers in this picture. And this is one data center alone. Now imagine that each one of these computers here in the picture would need an IP address. What if Microsoft had these massive data centers as well, and each computer required an IP address? What if Apple? What about the rest of the world? Your university or your school or your home and so on? If every computer on the internet required an IP address, we're gonna be very soon running out of IP addresses. And actually we are. There's a limited number of IP addresses that we can use. Roughly it's 4.3 billion. And right now we're actually running out of IP addresses. And the other question is, what if we don't want our IP to be public? Google has a public IP address that we discovered together because Google wants everybody to be able to access their website. What if I have my computer on my home network and I don't want it to be publicly available to everybody to access? This is when we use IP addresses that are not made public, i.e. private IP addresses. So a public IP address is any IP address that is directly accessible on the internet. For example, hackersacademy.com would have a public IP address, such as Google, such as Yahoo, such as Microsoft.com, and so on. A private IP address, on the other hand, is not accessible from the internet. So for example, right now, if you're connected to a school network or your home network, your computer would have an IP address that would not be accessible directly on the internet. So if you're connected to a private network right now, your computer would have one IP address from the following pools. These are the pools reserved for private IP addresses. If you want your computer to have an IP address that is not accessible on the internet, your computer would have an IP address that is picked from one of these three different pools. Anything from 192.168.00 to 192.168.255 to 255, which is a little bit over 65,000 IP addresses that you can choose from, or the second batch, which is a little bit over 1 million IP addresses that you can choose from, or the third batch, which is a little bit over 16 million IP addresses that you can choose from. So my IP address, for example, as you saw earlier, is from the first pool of 192.168.x.y. So if we want to take a very high-level bird's eye view of how IP addresses are assigned, let's have a look at this diagram. The globe symbol in the middle resembles the internet, and these 5 devices around it resemble public IP addresses that are connected directly to the internet. So for example, one would be google.com, the other would be Microsoft, Yahoo, Apple, and hackersacademy.com. These are 5 different websites with 5 different public IP addresses that are particularly assigned to them and unique to them. On the outermost circle are the private IP addresses of everybody's home, office, and school network. So all these desktops and laptops and even mobile phones that are not directly connected to the internet would have a private IP address. Right now, other than your desktop or other than your laptop, if your mobile is connected to your wireless router at home, your mobile would have an IP address assigned to it. So here's what I'd like you to do. I'd like you to identify at least one other private IP address on your network. The easiest way to do this is if you find what your IP address is and try to increment or decrement by 1. So if, for example, my IP address is 192.168.1.10, I would try to ping 192.168.1.11 or .1.9. Another way to do this is to start from .0 and increment it one by one until I discover another IP address. So go ahead and try and do that and see how many IP addresses you can discover. And remember to record your success. Now you know what an IP address is. What's the difference between a public IP address and a private IP address? To recap, a public IP address is an IP address that's accessible on the internet. It's publicly available, anybody can access it. A private IP address, on the other hand, is not accessible directly on the internet. So if you're connected to your home network, you're very likely to have private IP addresses on your laptop, on your desktop, and on your mobile. At this point in time, you might be right to wonder, how are you able to access the internet if you're using a private IP address? How is it possible that your machine with a private IP address is able to communicate with a machine on the internet with a public IP address? This is where NATing comes in place, and its sole purpose is to translate data from private IP addresses to public IP addresses and the other way around. This is an example setup we're going to be looking at, so we understand how NATing works. On the left-hand side, we have two machines. Let's assume you're at home, you have two laptops connected to your wireless router. So the first one has the IP address of 192.168.1.111, and the second one is 192.168.1.112. These two laptops at home have private IP addresses. Both these machines are connected to your wireless router. If these two machines need to talk to each other, it's very straightforward and simple. All they have to do is redirect the traffic through the router and talk to each other. As a matter of fact, the router doesn't need to even be there. If you plug in these two machines directly through a network cable, they would still be able to talk to each other. So if you right now go grab a network cable, plug it into one laptop and then plug it in another laptop, you just created a network and these two laptops can talk to each other, provided that they have IP addresses within the same range, such as the ones in our example. The wireless router though makes it much easier for this to happen. So instead of plugging cables all across your living room, all you have to do is connect your devices, your laptop, your desktop, your mobile, to the wireless router, and it just redirects the traffic wherever it needs to go. So the router in this case will see traffic coming from 192.168.1.112, and it will see that it is destined to 192.168.1.111, and all it does is that it redirects it from the source to the destination. The device in the middle, this represents your wireless router. You can see that on one hand, on the left hand side, you can see that there's an IP address of an interface of 192.168.1.1. So if you grab your wireless router right now, you're gonna see that there are different ports, different places where you can plug in a network cable. If you plug in a network cable in one of these ports, you will get assigned one IP address. If you plug in the network cable in another port, you get assigned another IP address, so on and so forth. So your router would actually have an IP address of its own, meaning that if the device at 192.168.1.112 wants to talk to the neighboring device of 192.168.1.111, the data will have to flow through the router at 192.168.1.1. So the path that the data will take is computer A, router interface, then computer B. This is networking in its simplest form. Two devices on the same network talking to each other. We're going to be showing you a video, an animated video in a moment, so you get a better understanding of this. Now the question is, what happens if one of these two machines want to talk to a server on the internet with a public IP address? You might have noticed by now that the router has two interfaces with two different IP addresses. So on the left hand side it has the 192.168.1.1. On the right hand side it has the 20.30.40.50, and this is a public IP address. So for example, if the machine on the left hand side at 192.168.1.112 wants to talk to a public IP address, in our case 8.8.8.8, the traffic will go first to the internal interface of the router with the IP address of 192.168.1.1, and then the router will have the job of translating this in such a way that it will be understood and routed to a public IP address. So internally what will happen is the router will take the data from 192.168.1.1 port and translate it to the other port at 20.30.40.50. And at that point in time, the data will be attached to a public IP address, making it possible for other devices on the internet to see it and communicate with it. And when the data is being sent back from the internet, it will reach the interface, the public interface at 20.30.40.50. The router will take this data, translate it to an internal IP address, and then forward it on to the destination. Perhaps a video will make it easier to visualize this. Let's have a look. So in our first scenario, our internal computers want to talk to each other. Both computers are at home with private IP addresses. 192.168.1.112 wants to talk to 192.168.1.111. And all it has to do is send the data to the router that will in turn forward it to the other machine. What if our internal machine now wants to talk to a public machine? The data will go through the router to the first interface at 192.168.1.1, then to the second interface, which has a public IP, all the way out to the internet, and then the other way around coming back in. Let's verify this. Let's have a look at what path our data is actually taking. To do this, let's go back to the command prompt and type ipconfig. This will show our IP address, and it will show us also the default gateway. The default gateway will be the IP address of the router's interface that does the NATing for us. There's another command that we can use in Windows called traceroute. And what this command does is, as the name suggests, it traces the route that our traffic takes to reach a destination. What we're doing now is we're doing a traceroute to hackersacademy.com to see the path that our packets are following. And as you can see, the very first hop that our data takes is the 192.168.237.2 IP address. In this case, this is the IP address of my router, which confirms what we have been talking about. For my machine on my internal network to be able to talk to hackersacademy.com, which is a public domain, the data will have to flow from my machine to the router that does the NATing and then gets sent to the internet. So here is your mission for this section. Go ahead and do a traceroute from your machine to Google and identify the IP address of your gateway. There's a very good chance that if you're on a wireless network at home, this is going to be the IP address of your wireless router. See if you can access this IP address and what you can discover on it. And remember to always record your success. Let's add one more piece to the puzzle of the internet. We already mentioned that IP addresses are a big part of the internet. This is the unique address for every machine that's publicly available on the internet that we want to talk to. However, obviously, it's really difficult to memorize IP addresses for every single website. Imagine that all the websites that you know by heart, instead of knowing the names of these websites, you have to memorize their IP addresses. And you'll have to type an IP address in your browser every time you wanted to open one of these websites. It's gonna be a major pain in the neck. A much easier way would be to memorize the names of these websites. Now the challenge here is that computers need IP addresses to communicate. So how would my computer know the IP address of Google when I type in google.com in my browser? This is the primary job of DNS. You can think of DNS as a database across the internet that keeps track of IP addresses and their corresponding names. So think of it, for example, as a big Excel sheet with two columns. In one column, you have the name of every single website, and in the other column, you have the corresponding IP address of every single website. These databases, these DNS databases, are spread all across the internet, and each one of them would have their own IP address. One of the most famous ones, for example, is the Google DNS database, which has the IP address of 8.8.8.8. So if you go right now and ping 8.8.8.8, you will get a response from it. If you traceroute to it, you will get a response from it. So when I open my browser and I type google.com, what happens is that my machine will send a request to Google's DNS and ask it, where is google.com? The Google DNS will reply with the IP address. Then my machine will communicate with the IP address of the google.com web server. The web server will hand me back the google.com website. So how do I know what DNS server am I using? Go back to the command prompt and type ipconfig/all. And one of the fields you'll see the DNS server IP address. Right now, this is the IP address of the DNS server that my machine will talk to whenever it wants to find the IP address of a website that I'm trying to visit. So in essence, that means if I change my DNS to a different IP address, my machine will not be able to find the information it's trying to fetch. It will try to communicate to a different server which wouldn't have the DNS database in it, which means I wouldn't be able to access websites on the internet. Let's verify this and see how it works. On the bottom right corner on your Windows machine, open the Network and Internet settings. And click on Change Adapter Options. We're going to be accessing the network adapter settings and changing those. Right-click on the network device and click on Properties. Scroll down to find the Internet Protocol version 4 and click on Properties. Currently, I have a setting that requires my machine to automatically find an appropriate DNS server. If I change that to a different IP address, let's say 111.111.111.111, and I save this change, this is now going to redirect my machine to a different DNS server. In this case, 111.111.111.111. So now when I ask for the google.com website, my browser is going to send a request to the 111 IP address asking it where is google.com. The 111.IP address does not have a DNS server on it. It doesn't have the DNS database, and as such, I'm not gonna get a response that says this is where Google is. And as you can see, I failed to access the google.com website. Let's go back and fix this. Going back to the TCP/IP options. And by the way, don't worry about what TCP/IP is. We're gonna be explaining this later on in the course. Let's go back and click on Properties, and now I'm going to put an alternate DNS server at 8.8.8.8. This is Google's DNS server. If I try to revisit Google again, you'll see that it works. Let's go find out why is this working now. Run the ipconfig/all command again, and you'll see in the DNS server settings, now I have two IP addresses for two different DNS servers. So what happened is, my machine tried to communicate with the first DNS at 111.111.111.111, and it didn't get a valid response. And as a result, it tried the other DNS, that of Google's, and that gave me the appropriate response. Make sure you go back and change the settings back to what they were. Here's your mission for this section. Identify what DNS you're using and answer the following questions. What's your DNS IP address? Is it a private DNS or is it a public one? This is the final piece that completes the big picture of what the internet is and how does it work. What are servers exactly and what do they do? We mentioned DNS servers, we mentioned web servers. To put it very simply, a server is a dedicated computer that usually is more powerful and provides some kind of service. So for example, the DNS server that has the DNS database serves information from the database to whoever asks for it. We mentioned Google's DNS server, which has the public IP address of 8.8.8.8. So basically, it's just a powerful computing machine, like your laptop, only a lot more powerful, which has the DNS database, which contains all the IP addresses and their corresponding websites. Whenever somebody wants this information, like we did in our previous video, we ask the DNS server to serve us the IP address of the google.com website. And what that server did is it served us that information. This is why we call it a server. A web server is another example. So a web server would have a website and it would serve you pages whenever you ask for it. So if you go to hackersacademy.com, our web server will hand you out the page that you ask for, the training page, the About Us page, and so on. It will be serving you these pages. This is why they're called servers. I'm going to show you quickly how a server is set up. On my current machine, I'm going to set up a web server now. This is my IP address 192.168.237.132. If I open my browser and I go to my IP address, I get an error saying web page is not available. There are currently no web pages available to be served on my own machine. So my machine does not currently have a server functionality running. Let's change this. Go to Control Panel, and I like to change the view to the smaller icons. Go to Programs and Features, and turn Windows Features on. This allows us to add more features to our Windows machine. I'm going to scroll down and find the Internet Information Services. This will help me publish a World Wide Web service. So it will help me publish on my machine web services, which basically is fancy talk for I'm going to publish a website on my own laptop. So I'm going to click that and turn it on and wait for the changes to apply. By doing that, I just switched on a web serving functionality on my own laptop. And as soon as the changes are finished, I'm going to go back to my browser and I'm going to refresh the page. And now as you can see, my laptop is serving a website. So practically what I've done is I turned my own laptop to a web server. It is now a machine that is serving websites to anybody who can access the IP address of my machine. Here's your mission for this section. I'd like you to retrace the steps you saw in this video and this time turn on the FTP server. If you don't know what an FTP server is, go and figure out. And I'd like you to figure out how you connect to the FTP server. Once you've successfully completed that, make sure that you turn them back off again and set the computer back to its default state. We don't want any additional services to be running on our machine for a very good reason. We're gonna find out later why. Let's revisit one of the first slides that we started with on this course. We mentioned that for you to be able to hack remotely, you would need 4 different components. You will need the IP address of the machine you're targeting, exposed remote service running on that machine you're targeting, vulnerabilities in that service, and an exploit to be able to take advantage of that vulnerability. In the previous section, we covered what the internet is and why IP addresses are needed, what they are, what's the difference between a public IP and a private IP, how DNS helps us translate domain names or URLs to IP addresses, what servers are, for example, what a web server is or what a DNS server is, and how each server has an IP address assigned to it. We learned how to discover the IP address of the machine we're targeting. Together, we discovered the IP address of Google in your country and the IP address of hackersacademy.com. So now that we know what an IP address is and how do we discover the IP address, it is time to move on to the next stage. In this section, we're going to be covering services, what they are, how do we find them, and how do we find information about them. So what are services and what are ports? We talked earlier about web servers. We went through an exercise where we set up our own laptops to become web servers. We switched on, if you remember, some features on our Windows machine, the World Wide Web publishing service, and that transformed my laptop to a web server. So I had a website being hosted on my own laptop. When that happened, my laptop became a web server. So for the context of this course, consider the service is what runs on the server. So for example, when my laptop became a web server, because I was serving a website on it, on my laptop there was a web service running. It was switched on and it was running, waiting for somebody to connect to it. Here's an example that will make it a little bit easier to understand. Think of services as mobile applications. Right now on your mobile device, there's a number of applications, such as your camera application, your social applications, your calendar applications, and so on. Some of these applications will require access to the internet, whereas some of the other applications will not. So if you have an Android phone, for example, and you try to install a new application, it will come up with a list of permissions that the application requires from you. Sometimes, or more often than not actually, one of these permissions is access to the Wi-Fi or to the internet. Because a lot of these applications would want to connect back to the internet to retrieve data and updates and so on. There are other applications though that do not require access to the internet. So for example, it's very rare for you to be updating your camera application. Although it's an application running on your mobile that you use to take photos and videos, it's very rare that you would go online and update the camera application alone separately. So although these applications or quote-unquote services are running on your mobile, some of them would be connecting to the internet and some wouldn't. The same applies to any computing machine or any server. When I transformed my laptop into a web server, the web server service would allow it to connect to the internet or would allow people from the internet to connect to it. There are other services, however, that would not require connection to the internet but need to be running for certain operations on your machine. Let me show you a video so that you'd have a better understanding of what I'm talking about. And feel free to follow along with this video. The more you practice, the better you understand. On your Windows system, go to the bar on the bottom, right-click and click on Task Manager. Click on More Details and then navigate to the Services tab on the top right corner. This will show you every single service running on your machine. Don't worry if you don't understand what all these services are for. It's not necessary for now. Some of them are very easy to understand, such as the Windows Firewall, for example, or your antivirus that's running. So here's what we're gonna do. We're gonna try to start and stop some of these services and see what happens. Let's go to the control panel and reinstall the World Wide Web service. So again, I'm going to set up my laptop as a web server. I scroll down to the Internet Information Services and I reinstall it. We'll give it a second, and when it's done, I go to my browser and I refresh my home page. And you see that now I have a website running on my machine. So in that context, my laptop right now is a server with a web service running on it. Let's try and find the exact name of this service. I regroup the services to filter out the running ones, and here it is, World Wide Web Publishing Service. This is the service running behind the website. This is what makes it possible for me to access a website. Let's see what happens if I stop this service. Go down and click on Open Services, regroup the services by name, and scroll down to find the World Wide Web Publishing Service. We can see in the status here that it's running. I'm going to right click on it and stop it. So right now, I stopped the service behind the web server. I'm going to go back to my browser and I will try to refresh the page. And as you can see, I failed to load the page because the web service behind the web server is not running. I'll go back, right click and start it again and refresh the page, and here you go, it's running again. So now we know what a server is and what a service behind the server is. Obviously, like your mobile has so many different applications, a server can also run multiple services. We've seen how many services were running on my machine. So for example, a server could be serving you websites and emails at the same time. Now the question is, how would a server know how to direct incoming and outgoing communication? So for example, if a server is receiving web communication, somebody is asking it for a website, how would it know that this is website traffic? And where would it direct to, as opposed to, say, for example, email traffic? This is where service ports come in place. Each service has an assigned port that accepts communication meant for that service. Think of a port as a doorway. And for that port to accept communication, it needs to be open. Again, such as a doorway. If it's blocked, it would not be able to accept any communication. So each service would have an assigned port for it, ready to accept communication as long as the port is open. These ports would have numbers, and a lot of these numbers are standardized around the world. So for example, if I'm going to be talking to a web service, there's a very good chance that I'm going to be talking to a port with a port number 80. If I'm going to be talking to a mail service or an email service, there's a very good chance that I'm going to be talking to a port number 25. So if you open your browser right now and type hackersacademy.com, you're going to be able to access the Hackers Academy website. Try, however, to type hackersacademy.com:8080, which is the stand port number for web. You'll see that you will get the same result. Why? Because your web browser will direct the traffic to port 80 anyway. So imagine here that you're talking to the Hackers Academy server. And at Hackers Academy, we provide two services for you. We have the website and we have the email. Whenever you're trying to retrieve information from our website, you are going to be communicating with port 80 on hackersacademy.com. Whenever you're sending or receiving emails, however, you are going to be communicating with port number 25 on hackersacademy.com. So here's your mission for this section. I'd like you to find out how many port numbers exist. What's the total number of ports out there? hackthisite.org has 3 services running on 3 different ports. Port number 22, port number 80, and port number 443. Don't worry for now again what TCP is. We're going to be explaining that later on. For now though, I'd like you to determine what these services are. What is the service running behind port number 22? What is the service running behind port 80? And what is the service running behind 443? We've already discussed what runs on port 80. So find out what the other 2 services are for. I hope you've been enjoying the course so far. It's essential that you follow the steps that we recommended in the beginning of the course. If there's anything you're stuck at or you do not understand, please make sure that you review the video a couple times, go do some research on your own, ask on the Hackers Academy forum, and if all that doesn't work, drop us an email. Send me an email personally and I will make sure to respond. So far we covered what the internet is about, what are the components of the internet and how does it work. We talked about what IP addresses are, the difference between public IP addresses and private IP addresses. And we explained that these are unique numerical addresses for every computer or server on the internet. We explained what's the difference between a regular computer and a server, and the fact that a server would have a service running on it, such as a web service or an email service, and that we can communicate with this service to send and retrieve data. We also mentioned that these services would have port numbers assigned to them. In the following section, we're going to be discussing how do these services work, on what basis. So get ready, because things are beginning to get more technical now. In this section, we cover what I like to call interview questions. If you are going to begin your career into ethical hacking, as a junior penetration tester or as a junior ethical hacker, you are required to understand certain concepts, without which it's very difficult for you to land a job. Whoever is conducting your interview wants to know that you have a very good understanding of certain concepts. And these are the concepts that are going to follow in this section to the end of the course. We're going to be covering what packets and protocols are, what port scanning, what vulnerability scanning, what exploitation is, and so on. Now keep in mind, like we said earlier, that there is no way we can cover everything in one course, or in multiple courses for that matter. There is a lot that one can learn. However, what I'm trying to give you here is the stepping stone into the world of ethical hacking. So once you know what a packet is and how does it look like, and what a protocol is and how does it look like, instead of me trying to teach you about every single protocol that's out there, which is an impossible task to do, what I would invite you to do is that you would go and study about all the common protocols. In this section, we're going to be talking about a few main ones that you definitely, absolutely should know about, that you cannot start without knowing about. Remember, this is the hacking course for beginners. So we're going to be helping you to begin in the following sections. And then later on, you want to go and expand your knowledge on your own. Let us begin by talking about packets. Between computers, data isn't sent whole. Whether you are communicating with another computer, another server, another mobile, whatever data is being sent between them wouldn't be sent as whole. When we say data, we mean pretty much anything that's being communicated: pictures, videos, documents, emails, etc. The sending computer would break the data down into what we call packets, and the receiving computer on the other end would reassemble these packets and see and read the data. For example, if the computer on the left-hand side wants to send a message to the other computer saying, "Hi, how are you?" it will break it down into different sections or different packets. Hi, how are you? And it will send them in that order. The receiving computer on the other end will reassemble these packets and then read the message as a whole, understanding that it's a question asking, "Hi, how are you?" in order for it to respond. How is this broken down and how is it reassembled on the other side? This is what protocols is about. Because there are some questions that we need to be asking ourselves right now. The first obvious question is, how do we make sure that the data is being sent to the correct recipient? Do I just blast the data out on the internet and hope that the recipient will get it? How do I know that it's being sent to the correct port? We mentioned earlier that some servers would be providing more than one service, for example, email and web. How would I know that the receiving server is getting the email on the email port and not on a wrong port? How would I know that my data's integrity is intact? How would I know that, for example, my email is being sent in the correct manner and we're not losing some words or some pictures or some quality of the pictures in our email attachments? How would I know that the recipient is able to restructure the data in a correct sequence? To answer these questions and more, we rely on protocols. In the world of networking, protocols are a set of rules dictating how to communicate. For example, when you're communicating over the phone, it's the protocol that you pick up the phone, say hello first, and then initiate the conversation. You wouldn't say hello before you pick up the phone. You definitely wouldn't initiate the conversation without answering the phone. It just wouldn't work. Similarly, in the world of networking, this is what protocols dictate and mandate. Now, for the internet to work, we would need a number of protocols stacked on top of each other. What do I mean by that? Going with answering the phone example. In some countries, for example, it's customary and it's the protocol to start with a courteous conversation, asking about the other person, how they are, how their family is, how they've been, and so on. You wouldn't just pick up the phone and say, "Hey, how's it going? I want this." That would be incredibly rude in some countries. In other countries, maybe that works. So there are different protocols depending on where you are and who you're communicating with. The sequence, for example, would be: first, you hear the phone ring. 2, you pick up the phone. 3, you would answer the phone, saying hi. 4, the other person would respond by asking a number of questions. How are you? How you been? How's the family? And so on. And then 5, the communication channel is open to exchange any kind of communication. The Internet Protocol, or the IP, which is the protocol that we mentioned very earlier on in the course, is one protocol that has a simple job of labeling communication with a source and a destination address. We've seen what IP addresses look like. These numbers have the only purpose of taking care of the recipient and the sender. So the Internet Protocol has the job of just delivering stuff. It doesn't worry about the order of delivery. It doesn't worry about whether it's being delivered in the correct order. All it does is that it knows who the address is and who the recipient is, and it just delivers. So if we look at an IP packet, this is what it would look like. This is an oversimplified IP packet, obviously. We're going to be looking at actual packets in a moment. But for now, an IP packet would look something like this. It has a source address of the sender, it has the destination address of the recipient, and some other kind of data that we really don't care about at this point in time. Another protocol that is very common on the internet and in networking is the Transmission Control Protocol, or TCP in short. And this is the protocol that handles the correctness of the order of the packets being sent, whether a packet has an error in it, or whether a packet has been lost or not. So for example, if I'm sending the "Hi, how are you" message from one computer to another, the Internet Protocol would look after who the sender is and who the recipient is, and would make sure that the message has been delivered to the correct recipient. The TCP protocol would make sure that the message is being sent in the correct order. So the hi is being delivered before the how and not the other way around. And it will also make sure that the packets are correct, the content of the packets is correct. So for example, the how is being delivered as a how, not as a who. And then lastly, it will check for lost packets. So if a packet has been lost on the way, has been dropped for whatever reason, it will ensure that the packet is being resent. For this to happen, the communication needs to be initiated in what we know as the TCP handshake. The initiation of the phone call, when you hear the phone ring, you pick it up and you say hello. This is very similar to what a TCP handshake is. The TCP handshake works as such. The sender, whoever wants to initiate communication, will send one packet called the SYN packet. This is the synchronization packet, which is basically a packet that says, hi, I would like to talk to you. The recipient, on the other end, will respond with a SYN ACK packet, which is an acknowledgement of the synchronization message. It's similar to a response saying, yes, I hear you, let's talk. And then the initiating end will send one more packet, which is the acknowledgement packet saying, I acknowledge that you can hear me, now we can start the communication. So when it comes to phone conversations, it's similar to you hearing the phone ring. This is the SYN packet. Somebody is asking to talk to you. You pick up the phone and you say, hi, this is you acknowledging that you heard the phone ring and you answered it. You're ready to talk. And then the other end would respond by saying, hey, this is them acknowledging that they can hear you too on the phone, and then the communication can begin. And here's what a TCP packet would look like. It's a little bit more complicated than the IP packet. All the IP packet had was a source address and a destination address. The TCP packet, on the other hand, has more information. It has the source port and the destination port. So if I'm talking to a web server, we mentioned earlier that it's very likely I'm going to be talking to port 80, which is the standard port for web. So I would know that in my TCP packet, the destination port would be 80. The source port, however, would be something special to me, which is the port where my data is leaving from. It doesn't have to be port 80, it could be any port. The third field that you see here is the flags. What we mentioned earlier in the TCP handshake, the SYN, SYN ACK, and ACK, these are called flags. And you can see these on the TCP packets. And then there's a whole bunch of other stuff that we don't care much about at this point in time. So remember when we mentioned that for the internet to work, we would need multiple protocols stacked on top of each other? This is what a TCP IP packet would look like. If you are in the world of networking or IT, you would have heard the term TCP IP so many times. And if you get into the world of ethical hacking, or IT for that matter, you cannot go one day without talking or hearing about TCP IP. TCP IP is short for TCP over IP, and it basically is a packet of TCP stacked on the packet of IP. So in this example, we have a packet of IP taking care of the source address and the destination address. I'm communicating to a web server, so I know that I am the source address and the destination address would be, in that case, let's say hackersacademy.com. The IP packet's job is done. On top of it, I would know that I'm communicating from X port to port 80 on the Hackers Academy server. And if I'm initiating the conversation, the flag on the TCP packet would be the SYN packet. So what is the web traffic exactly? There is the IP packet taking care of the source address, the destination address. There's the TCP packet taking care of the data sequence, the error correction, and the drop packets. But what is the web data? The web data is in a third protocol called the Hypertext Transfer Protocol, the HTTP. HTTP is the basis of data communication on the internet, on the World Wide Web. This is how we transfer graphics, video, audio, text, and links. And it works similar to TCP. So for example, if I'm trying to retrieve the logo from hackersacademy.com, I would send what we know as the GET request, an HTTP GET request. I will ask the server to give me the logo. The message that I would send would tell the server that I want to get the logo. The server will respond with an acknowledgement message saying, I acknowledge your request. And then the server will send another message saying, here's the logo. So now an HTTP request would look something like this. You have the IP with the source address and destination address, my source address and the destination address of hackersacademy.com. You have the TCP taking care of the correctness and the sequence of the data and so on, with the source port from my machine to the destination port of 80 on the Hackers Academy. You would also have the flags of the TCP packet depending on which part of the communication we're on. And then you would have the HTTP stuff that we just mentioned. For example, the logo from hackersacademy.com website. Alright, so enough theory. Let's have a look at what packets actually look like. Download the packet capture file and open it using Wireshark. I've pre-captured some packets for you that I'm going to walk you through. So now you can see what a TCP packet looks like, what an IP packet looks like, and how the HTTP communication looks like. If you have correctly installed Wireshark, all you have to do is, after you download the packet capture file, double-click on it and it will open automatically in Wireshark. There are a total of 7 packets in this capture, and we're going to walk through them one by one. First, let's talk about the interface of Wireshark. On the left-hand side, you have the sequence of the packets. So you can see that this is the first packet where the communication capture started, and this is the last one, number 7, where I stopped the capture. This is the time where the packets were captured. You have the source IP address and the destination IP address. You have the protocol of the packet captured, the length of the packet, and some more information. So let's click on the first packet and expand it. Skipping to the third field, you can see that this is an Internet Protocol version 4 packet. So this is an IP packet with the source IP address of 10.10.192.92. This is my machine's IP address. And the destination is 94.201.252.25. This is the IP address of Google. This is the Transmission Control Protocol field, or the TCP field. The TCP communication is leaving my machine from the source port of 63379 to the destination port of 80. So now I can tell that I'm trying to talk to this IP address, the Google's IP address, on port 80, which means that I'm talking to a web service. If you go down a little bit, you will see that there's a SYN flag being set. This is the first packet of the TCP three-way handshake. So here I'm initiating the conversation with the Google server. Let's have a look at the second packet. Now the source has changed. So now the communication source is Google's IP address, and I am the destination in this case. The packet I'm receiving is a TCP packet with the SYN ACK flag set on. Let's have a closer look. This is the IP information, the source and the destination, which we already know by now. And this is the TCP information. So now the source port is 80 and the destination port is 63379. The information between the first packet and the second packet has now been inverted. In the first packet, number 1, the source was me, the destination was Google. The source port was my source port, and the destination was also Google's at port 80. Because I was initiating the conversation, it was me who started the conversation. And then Google responded. So now the source is Google and the destination is myself. And the response came from port 80, which I started communicating with, to the destination port on my machine. You can see now that in the second packet, the TCP flags SYN ACK are set. So Google has acknowledged my SYN packet and is ready to start communication. The third packet I send is the last in the TCP handshake, which we expect to have the ACK flag on. So now again, I'm communicating with Google, sending a TCP packet to port 80 with the ACK flag being set as on. So now, my TCP handshake is done and the conversation is ready to begin. I have my TCP stacked on top of IP. Now it's time to use the HTTP. The first thing I'm asking Google to do is give me an image, the Google logo. And I do this by using the HTTP protocol GET request. Remember what we talked about? In HTTP, we have GET requests that we can use to retrieve information from the web. And here what I'm asking for this logo. which lives on Google's server under the images directory, branding, and so on. So let's have a closer look. The first thing you'll notice here that there's another additional field. The previous packets, if we look back at it, had the IP and the TCP. Now we have the IP, on top of it TCP is stacked, and on top of it is the HTTP. Let's open this and have a closer look. This is the HTTP GET request. So the server will know that I'm asking for the following URL, images/branding/Google logo, and so on. I'm retrieving or I'm asking for this logo. So how would Google respond for my request? We see that in the next packet. Notice that there is no longer an HTTP field here. All what's happening is that Google now is responding with an ACK. It's saying, I acknowledge your request and I'm going to send you the logo. And then it follows it with an HTTP packet of its own. So now the HTTP communication has been initiated as well, and it's happening, to which my machine will respond with a TCP ACK packet. Let's summarize. I want to retrieve an image file, a logo file from google.com. The first thing I do is I initiate the conversation. I give Google's phone a call, and this happens through the TCP SYN packet. Google hears the phone ringing and acknowledges my call and responds by a SYN ACK. Google picks up the phone and responds by saying hi. I respond by saying hello. So I acknowledge Google's acknowledgement, and in the third packet, I respond to Google's response. The first three packets are the TCP three-way handshake: SYN, SYN-ACK, ACK. After the initiation of the conversation, it's time for me now to ask for what I want, and I send the HTTP GET request using the Hypertext Transfer Protocol. Google acknowledges my request and continues talking HTTP to me. And then I acknowledge Google's HTTP communication. Here's your mission for this section. We saw the flags on the TCP three-way handshake: the SYN flag, SYN-ACK flag, and the ACK flag. Find out what other flags TCP uses and what are they used for. Then, using Wireshark, capture traffic from hackersacademy.com. Try to identify the source and destination IP addresses. And try to identify the source and the destination port you're communicating from and to. In this section, we're going to set up a lab on our machine. This is a virtual environment lab, so you can install any operating system you want in the virtual machine. You can keep it for as long as you want, practice on it as long as you want, and do to it whatever you want. It's very easy to reset, and it's 100% legal. To do this, we're going to install a piece of software called VMware Player. Go to the VMware website, and under Products, find the Workstation Player. Click on Try it for free, and download. Once the download is complete, double-click on the setup file and follow the instructions. If you're prompted for a license key, just click on Use for Free, enter any email, and click on Finish. And now the setup is ready. The second step in setting up our lab is installing the target environment. Go to the URL provided and download the Metasploitable operating system. This is a Linux operating system that has been set up and configured in such a way that it is vulnerable and exploitable. Once you've downloaded it, extract the file. And then double-click on the VM file. When you do that, it will automatically open in the VMware Workstation Player. It boots up. And now it's ready for you to log in. The username and the password are the same, msfadmin. To find out what the IP address of your target machine is, type ifconfig. And make sure that there is a connectivity between your Windows operating system and your target machine. You do this by opening the command prompt on your Windows system. And type ping and put the IP address of your Metasploitable Linux. You should be able to see a reply from the IP address you're pinging. And now you have a lab setup. Note down the IP address of the Metasploitable machine. This is going to be your target IP address going forward. It's time to get our hands on some hacking tools. Before we begin though, our lawyers have advised that we share this disclaimer with you, so please take a moment and make sure that you read it. Now that you read the disclaimer, let's begin. Let's revisit one of the earlier slides. We said that to be able to hack remotely, you would need to have 4 different things. 1. The IP address of your target. 2. An exposed remote service running on the IP address. 3. Vulnerabilities in services. And 4. An exploit. We've talked in length about IP addresses, the Internet Protocol, and other protocols. And the reason we went into such details is because now it's the time that we explain how you can discover remote services running on your target. And we do this using a technique called port scanning. So what is port scanning? Remember when we said that different services have different ports? So for example, the web service would have port 80 open. The mail service would have port 25 open. And so on. So an open port is an indication that there is a service running behind it. Port scanning is a technique of identifying open ports and identifying the service running behind that port. And it happens by connecting to each port and analyzing the response that we get from this connection. Meet Nmap, or Network Mapper, your first hacking tool. Nmap started as a port scanner, and then it developed into much more than just that. Now it does things like operating system identification, service identification, and a whole bunch of other things that we cover in more advanced courses. By default, when we're doing an Nmap scan, Nmap does a SYN scan. We'll talk about what that is in a second. The response to the SYN scan will determine the state of the port. If you get a SYN ACK response, that means the port is open. If you get a reset response, that means the port is closed. And if you get no response, that means the port is filtered. What does all that mean? Remember when we talked about the TCP handshake? We weren't talking about this just for the heck of it. There's a reason why we were explaining all that. A SYN scan happens as such. The port scanner, your Nmap tool or any port scanner, if you're doing a SYN scan, will start by sending a SYN packet to the target. So let's say, for example, you try to identify whether port 80 is open. What Nmap does is that it sends a SYN packet, so it starts the TCP 3-way handshake. What do we expect in response to the SYN packet? If you remember, the normal response is a SYN ACK packet. And this is where the port scan stops. Let's compare that to the three-way handshake. The three-way handshake sends the SYN packet, expects a SYN ACK packet, and then responds by an ACK packet. So when we did the packet analysis in a previous exercise, when we were initiating the conversation with Google, we saw through Wireshark that the first packet that we sent was a SYN packet. Google responded with a SYN ACK packet, and then we responded back with an ACK packet. That was our three-way handshake, trying to communicate with port 80. A SYN scan, however, wouldn't complete the three-way handshake. All it does is that it sends a SYN packet to the port you're trying to scan, and it waits for the response. If the response is a SYN ACK, that is an indication that the port is open and is ready to communicate. And this is where it terminates the scan. It stops, because now it has all the information that it needs. If the answer, on the other hand, is a reset packet, that means the port is closed, and we cannot communicate to the port. If we get no response, that means chances are that the port is filtered. What do we mean by filtered? That means there's some kind of a network security device, such as a firewall for example, controlling access to this port. It might have detected that you're doing a port scan and it dropped your packet. It wouldn't allow you to communicate with this port. And as such, we assume that the port is filtered. Installing Nmap is pretty straightforward. You go to the Nmap download page, download the executable file, and just follow the instructions. Using Nmap is pretty straightforward. All you have to do to perform a default scan is write nmap space the target. For this exercise, we're going to be scanning hackthisite.org. This is a hacking practice website that gives permission to everybody to try and hack it. And as you can see, Nmap has started. To see what the progress is, you can hit the enter or the return key. Every time you hit the enter key, you'll get an update of how long the scan has been going on and how long is remaining. At the moment, we have about 10 seconds remaining. And here we go, the scan has finished. If you look at the results, it shows that there are 3 ports open: SSH at port 22, HTTP port 80, and HTTPS port 443. Here's your mission for this section. I'd like you to explore the other options for Nmap scans. We mentioned that the default type of scanning is a SYN scan. There are other types of scanning. Try and find out what these are and how do they work. Following that, I'd like you to perform an Nmap scan against the target machine in our lab. See how many ports you identify as open, and try to figure out what are these services running behind these ports. Do a little bit of research and see if you can determine what these services are and what are they used for. By now, you're able to identify the IP address of your target machine. And using port scanning, you can also tell what ports are open and what services are running behind these ports. The next step in the hacking process is to identify vulnerabilities in these services. And we do this using a technique called vulnerability scanning. In the world of information security and ethical hacking, a vulnerability is equivalent to a weakness. The simplest example of a vulnerability is an easy-to-guess password. So for example, if you set up your email with an easy-to-guess password such as your name, the name of your dog, or the name of your mom, This is considered to be a vulnerability. Anybody who knows your name, the name of your mom or the name of your dog, might be able to guess your password. And that means that you've chosen a weak password, making your email vulnerable. Vulnerability scanning is the process of identifying these weaknesses automatically or using automated tools. So let's say, for example, you have a wireless router at home, and your password protected the access to the wireless router. A vulnerability scanner might be able to identify this weak password by trying multiple passwords in a very short period of time. So instead of you trying these passwords one by one manually, a vulnerability scanner would do this for you automatically and much faster. And this is what vulnerability scanning is about. It's trying to identify weaknesses using automated methods and automated tools. One of the best vulnerability scanning tools out there is called Nessus. It's free for home use. You can download it from the Tenable.com website and use it to scan our virtual environment target machine. To download Nessus, go to the products page and find the Nessus Home tab. Fill in the registration form and you'll be redirected to the download page. Click on download, choose the operating system. In this case, I'm going to download it on my Windows machine. Click on agree. And when the download finishes, click on the setup file and follow the instructions. When the setup finishes, your browser is going to open and redirect you to the Nessus setup page. Take note of that page. It's at https://localhost:8834. This is how you're going to be accessing Nessus page from now on. Click on continue and set up a username and a password. This is the username and password you're going to be using to log into the Nessus interface going forward. Get the activation code from your email. You should have received an email by now after you completed the registration form. Put in the activation code and click on continue. Nessus is going to take some time to finish downloading some extra stuff and some plugins. Might take a while, so be patient. Once that's complete, log in using the username and the password you set up previously. And with this, your Nessus installation and setup is now complete. Now let's use Nessus to scan our Metasploitable target machine. Before we do that, let's verify the IP address of our target machine. In this case, the IP address of my target is 192.168.140.128. Take note of this IP address. If you're not logged into the Nessus interface yet, make sure you do that by going to the https://localhost:8834. Type in your username and password and sign into Nessus. Once you're logged in, you want to create a new scan. So click on the new scan button. You're going to see a number of templates in front of you. We're not going to be discussing all of that. We'll do this in more advanced courses. For now, we'll just stick to the basic network scanning option. So click on basic network scan and give the scan a name that will make sense to you. Mine, I just call it my first scan. And in the description box, you can insert more details if you want. I just typed the IP address plus full port scan. I'm going to explain why in a second. In the target box, I'm going to fill in the IP address of my Metasploitable machine. Once done, click on the Discovery section. In the scan type, if you click on the drop-down menu, you'll see three different options: Port Scan Common Ports, Port Scan All Ports, or Custom. Remember in the protocol section when we talked about the TCP, I asked you in your mission to find out how many TCP ports are out there. If you choose the Port Scan Common Ports option, your port scan is going to be limited to a number of common ports. However, if you choose the Port Scan All Ports, it will try and scan for every single TCP port, which is much more comprehensive. However, it takes a longer time. But because we're scanning only one target, we're going to be going with the more comprehensive option, and we're going to choose all ports. And this changes the settings. It reflects in the settings below telling us that now we're going to be scanning all ports from 1 to 65535. Now our scan is set up and complete. We click on the play button and the scan is running. At any point in time, you can click on the scan, see the progress, and check the results. The results will continue to populate as the scan runs. It's going to take a while, so we're going to leave it for now and come back later. If we click on the vulnerabilities, we can go through them one by one. And now the number of vulnerabilities have increased even more. We can see there's a number of critical vulnerabilities, a number of high, and a number of medium vulnerabilities. As the scan goes, we can click on every one of these vulnerabilities and find out more information about it. Each one of these is a potential weakness that we can exploit to gain access over our target machine. As an ethical hacker, your job is to go through this report and test for these vulnerabilities one by one. Just because a vulnerability is there in the report doesn't mean that we can exploit it. It could be a weakness, but that does not mean that we have the tools or the programs that allow us to take advantage of this weakness. So you can click on any vulnerability if you want to read the description and find out more information about it. How we take advantage of these vulnerabilities is what we're going to be learning in the next section. Your mission for this section is to replicate what I've done. Install and set up Nessus, log into it, and perform a scan against your Metasploitable machine. Before we jump into the exploitation section and start breaking into our target and gaining remote access, let me reiterate a very important point. I already mentioned that there are some vulnerabilities that are not exploitable. What does that mean? That means that there are some weaknesses that we cannot take advantage of for the lack of certain tools or programs that didn't even exist to allow us to take advantage of this vulnerability or this weakness. Let me put it in another context. Let's say, for example, somebody is trying to pick a lock. As you have probably already seen in movies, there is a certain tool set that has multiple lock picks for different types of lock. So let's say you're trying to pick a lock of a certain type, but you don't have in your toolbox that particular lock pick. So even though you know that this lock can be picked, you know that you are able to open it, you might not have the exact tool that you need to be able to do that. And there could be multiple reasons for it. So for example, that tool could be super expensive and you cannot afford it. Or it could be a tool that is developed by somebody that is not willing to share. So you know it exists because maybe that person has demonstrated how it's done. They published a YouTube video about it, but they did not share the tool. So what that means is that that padlock is actually exploitable. It's weak, it's vulnerable, and you can take advantage of it if you have the right tool. But unfortunately, you don't have the right tool. And this is an all too common scenario for people who are getting into ethical hacking. There's a lot of companies that develop exploits for vulnerabilities or for weaknesses, but they do not publish them. Instead, they sell them for millions and millions of dollars for people who are willing to pay. Mostly, these would be people who are in law enforcement, for example, or military or governments. So we know that a certain protocol or a certain service has a vulnerability and it has been reported, but we don't have the tool to exploit it. All right, so how do you find out what are the vulnerabilities or the weaknesses that we can actually exploit? Lucky for us, Nessus provides a very easy way to do that using the Nessus filters. So let's take an example of this vulnerability that says critical, VNC server password. Now, if you look at the details of this vulnerability, on the right-hand side, you'll see some details that describe the vulnerability. And then if you look down, you'll see the vulnerability information saying that this is exploited by Nessus, true. So this particular vulnerability was actually exploited already by Nessus. Remember when I was explaining what a vulnerability scanner is and I said, imagine you have a wireless router with a weak password and instead of you trying these passwords one by one manually to guess the password, Nessus will do that automatically for you. This is exactly what Nessus did here. Nessus tried a bunch of passwords until it realized that the password actually works, and it was able to exploit or break into that service using the weak password. So let me go back to the vulnerabilities and notice the filter section here. Let's click on that. And in the filter, you see that there are multiple parameters where we can filter out the report or the display of the report. And one of these that we've already seen is exploited by Nessus. So let me scroll down and try to find it. Obviously, there are a lot of other parameters that we can look into, but I don't want to go into the details of each and every one of them. Let me just find the one that I want. I'm going to look at the exploited by Nessus, and I'm going to keep it as true. I'll apply the filter, and look at this. So this filters out the entire report for me and picks only the vulnerabilities that were exploited by Nessus. And for now, we have only one. So now if I click on this, and I don't know if you've noticed before, but if you look at the output says that Nessus logged in using the password. So Nessus actually took the action of fully exploiting this weakness, fully taking advantage of it to verify it 100%. So Nessus logged in and got access to that machine, to the remote machine, using the password. Okay, so this is only exploitable by Nessus, but are there other frameworks that can be used to exploit vulnerabilities? And of course, the answer is yes. So instead of looking at exploitable by Nessus only, let me see if there are other vulnerabilities that are exploitable, just generally exploitable using any framework or any tool. So I'll change the filter to exploit available, and I will apply that. And look at this. Now the results have increased, of course. So we see different vulnerabilities that range from critical, high to medium, and this is a very important point, by the way. This is to tell us that we don't just only look at critical vulnerabilities. Some medium vulnerabilities can allow us access in one way or another to the affected system. So of course, these vulnerabilities are exploitable using different means. Let's look at the first one. And if we look at the Debian OpenSSH random number generator weakness, you'll see that the family says gain a shell remotely. An easy way to think what a shell is: when you open the command prompt on your Windows to type commands, for example, like ping or ipconfig and so on, this is a shell or a command prompt. Now imagine if you had this exact command prompt popping up on your screen, but allowing you to control a remote computer. So as if you are sitting on the remote computer with the command prompt open and running commands. This is what we call in ethical hacking or penetration testing a remote shell. And this is usually the ultimate target for a hacker because it allows you full access to the computer if, of course, you have administrative access. But if we open the vulnerability and we look at the exploitable with section, you'll see that this is exploitable using something called Core Impact. And this is an exploitation framework that is sold for a certain amount of money, which is quite expensive actually, and not everybody can afford it. So now we know that this service is actually weak, it's vulnerable, and we know that we can exploit it. However, to be able to exploit it, we need to get our hands on a tool called Core Impact, which costs quite a big sum of money. Now, assuming that we cannot afford this because, let's say, we are individual consultants, we're working for ourselves, we don't work for a company that can afford this kind of tools, then we will not be able to purchase this tool, and we might even give up on exploiting this particular weakness. Now, in the next course, the Kali Linux tutorial course, we will show you how to exploit this manually without using any tools. But for now, for the sake of this course, we will have to assume that we cannot exploit this vulnerability and we have to move on and look at other vulnerabilities. So let me go back to the vulnerabilities and let me change the filter to look for something called Metasploit. In the next section, we will see how Metasploit works in a bit more detail. But think of it this way for now. Just like I explained what Core Impact is, it's a framework that has exploits that allow us to take advantage of vulnerabilities. Metasploit is exactly the same. The only difference, though, is that Metasploit has a free version, very much like what Nessus has in terms of a free version. So you are able, and you will see how to do that, to download and set up Metasploit and use it to run some programs or run some exploits against the target system. So if we can find any vulnerabilities that are exploitable by Metasploit, then we are in luck. So let's apply this filter and choose the Metasploit exploit framework and see what we get. Perfect. So we have a number of vulnerabilities that we can actually take advantage of using Metasploit. And we're going to be seeing how to do that in the next section. Now, if you want to clear the filter, it's pretty straightforward. You go back to the Filters tab and you clear the filter. So the whole point of this was to re-emphasize a certain concept that not all weaknesses or vulnerabilities are exploitable and not all of them you can take advantage of. There's also a very important point that I would like to mention. Nessus is a tool. It's an automated tool. In other words, it will make mistakes. This applies not just for Nessus, of course, but applies for every single tool. We make mistakes, tools make mistakes, and they miss out on certain things. And this is why you as an ethical hacker or as a penetration tester, you should never ever rely on one tool. In the next video, I'm going to be showing you how we can use Nmap to find out more vulnerabilities that are potentially exploitable that Nessus did not report in this particular scenario. So keep in mind that we have now 4 vulnerabilities that are exploitable by Metasploit, or we assume are exploitable by Metasploit. We have to verify this later on. And I'm going to be digging a little bit more using Nmap to find out if there are any other vulnerabilities that could be potentially exploitable by Metasploit, but that Nessus might have missed out on. Alright, let's continue. And now we reach the most exciting bit of hacking. We've identified the IP address of our target machine. We identified what services are running on the machine, and we were able to see if there are any vulnerabilities affecting these services. The next and last step in this course is to take advantage of these weaknesses and exploit them in such a way that we can gain remote control over the target machine. And we do this using exploitation. So what is an exploit? An exploit is taking advantage of the weakness. We want to take advantage of the vulnerability that we identified. Just because we found out the vulnerability doesn't mean that we now have control over the system. If the vulnerability is there, but we cannot take advantage of it, it's of no use to us. So an exploit could be as simple as guessing the correct password, for example. If your target machine has a weak password and you're able to guess it and connect to it remotely, you have successfully exploited the machine. The vulnerability in that case was a weak password, you took advantage of it, you exploited it, and you got full control over the machine. This is what an exploit is in its simplest form. A more complex exploit could be writing a particular program specifically tailored to the target. And this comes at later, more advanced stages in your hacking career. Luckily for us, there's an amazing tool that packages thousands and thousands of exploits in one package. And the tool is named Metasploit. You can either download and install Metasploit from their website, or you can use it from one of the readily available Linux distributions that are specially configured for ethical hacking. Installing Metasploit is pretty straightforward. All you have to do is go to the Metasploit/download page, and you'll see 2 versions of Metasploit, the Metasploit Framework Open Source and the Metasploit Pro. You want the open source one because this is the free one. When you click on the link, you will get redirected to a GitHub page. You'll go and choose the operating system, in our case it's Windows, and click on download the latest Windows installer. Once the installer is finished downloading, you double click on it to execute it, and from there on it's a matter of next until the installation finishes. Now I have to tell you, before you start the installation, you have to either disable your antivirus or create an exception. I did forget to do that during this installation, so you will see me frantically trying to disable my AV and my firewall as the installation happens. If you don't do that and you try to start Metasploit, it either will not start because it wouldn't have installed properly, or the antivirus will kill it while it's starting and you will see the window just shutting down. The reason we disable the firewall is because when we break into a remote system using Metasploit, it creates connections from and to the target host. And we need to either create exceptions of these on the firewall, or we need to disable the firewall. Now, ideally, and this is important, if you are using this on your day-to-day operating system, which I don't recommend to start with, but in case you're doing that, you don't want to disable the firewall, you don't want to disable the antivirus. You just create exceptions. So you create an exception for the antivirus not to scan or not to stop Metasploit, and you create an exception through the firewall to allow Metasploit to communicate with the target hosts. Because I'm using a virtualized environment and it's a contained environment, I'm fairly comfortable disabling both the antivirus and the firewall. I do recommend you do that, but the choice is ultimately yours. So now that the installation has finished, you need to go to the directory where you installed Metasploit. By default, it installs under the C directory, Metasploit framework, and then you need to go to the bin folder, and this is where you have the scripts that will start up Metasploit. The one that I want to start is the msfconsole.bat. I double click on this and it opens up a command prompt. Notice that the command prompt here is running under C Windows/System32, which tells me that I am running as administrator. This is another prerequisite to run Metasploit successfully. It needs administrative privileges. So you need to disable your antivirus or create an exception. This is one prerequisite. You need to disable your firewall or create an exception. This is the second prerequisite. And the third prerequisite is to run it as administrator. If you are running Metasploit for the first time, it is going to take a while, so please be patient. Don't panic if you are staring at this empty command prompt and you think it's not working. Give it a few minutes, it will load ultimately. So there we go. Here we have Metasploit up and running. You might have noticed that there was a warning when it started loading. You can ignore that for now, don't worry too much about it. Now I'm going to just change the properties here very quickly to make the font a little bit larger so it is easier for you guys to see what I'm typing on my screen. Alright, go ahead, make sure that you have set up your Metasploit successfully and it's working, it's up and running, and then let's carry on with the rest of the videos. Now, let the fun begin and let us start with the exploitation section. The first exploit I'm going to be showing you, I want to show you to demonstrate two things. To remind you or redemonstrate the concept of client and server, and to demonstrate the concept of a remote shell. So let's go back to our Nessus report. Have a look at this, bind shell backdoor detection. Let's open this vulnerability and read what Nessus says. It says Nessus was able to execute the command ID, which is a command that you can run on Linux to see what is the ID of your user that you're logged in as. So Nessus was able to execute the command ID using the following request, and it shows the request and the output of the command ID, meaning that Nessus was able to connect remotely to the host and run a command on the host. Now, if you look at the output here where it says root at metasploitable:/#, this is the command prompt for the root user, which is the admin user on Linux, the most powerful user on a Linux operating system. So Nessus was somehow able to log in remotely to that machine and run a command as root. If we look down a little bit, we'll see that this affects port 1524. So what does that mean? This means that there is a server or a service running on port 1524 on the target host, and it's listening and it's waiting for incoming connections. If somebody is able to successfully connect and communicate with port 1524, that somebody, hopefully this is you, will be able to run commands remotely on that system through a remote shell. In other words, there's a server or a service on that system and I need to be able to connect to it using a client. So I need a piece of software that allows me to log into that service. In other words, assume that was the FTP server. It's an FTP server running on port 21. What do I need to log in or to communicate with that server? I need an FTP client. Similar to if there was a web server running on the target host, what do I need so I can connect and communicate with it? I need a web client. In other words, I need a browser, a web browser. So we're all familiar with a web browser. We all know that we can use the web browser, which is a web client, to talk to a web server on port 80 or port 443. In this case, however, we have a service that we are not all too familiar with that is running on port 1524, which we haven't seen before. So what do we use in this case? Do we use a web browser? Do we use an FTP client? Or do we use something else? When I first started hacking, many years back, One of the very first tools that I learned to use was Telnet. And Telnet is a tool that you can use to connect to any port that you want and see the response from that port. Now with Windows 10, this does not come installed by default, so we have to go ahead and install it. So I'm going to open the control panel. In the control panel, I'll go to the programs, and I'm going to go to the turn Windows features on or off. In the Windows features, I'm going to scroll down to find the Telnet client, and I'll click OK to install the Telnet client. Once this is installed, now I can use the Telnet client from the command prompt. So let me open the command prompt and change the properties so it's a little bit clearer for you guys to see. And now all I have to do is type Telnet, the IP address that I want to connect to, and the port number that is affected. In our case, it's port 1524. And look at this. I immediately get back a prompt that resembles a root prompt on the remote target. In other words, I have a remote shell. I have a remote root shell, so I can run commands as root. So to replicate what Nessus has done, I can type the ID command and look at the output. It says I am the UID root or I am the root user. So I have effectively managed to very easily compromise the remote host just by connecting to port 1524, which presented me with a remote command prompt that allows me to run commands remotely on the targeted operating system. So I can run another command like ls, for example, which lists the contents of a directory, and I can see the contents of the directory. This is a little bit skewed because of the way the Telnet works. And if I want to terminate the connection, I type exit and I get back to my Windows command prompt. So hopefully I was able to demonstrate to you again the difference between the client and the server. To reiterate, the server is listening on the Metasploitable machine, on the target machine, on port 1524, and I needed a client to connect to that server. So I used Telnet to be able to connect to it. Once I connected to it, hopefully I was able to demonstrate the second concept, which is the remote shell. And this is what came up when you were looking at the prompt and you saw root at Metasploit with the hash sign. This is the remote shell that allows me to execute commands and run commands remotely on the target machine. So now that this is clear, here's your mission for this section. Look at the VNC server password. This is another vulnerability that will allow you to get a shell remotely. However, you should be able to get a graphical shell in this case. In other words, instead of getting the text-based command prompt that we just saw, you should be able to log into the target machine and get a graphical interface. Now again, very similar to what we've done right now, there is a VNC server running on that machine, and you need to use a VNC client to be able to connect to that server. So I'll leave that for you to figure out. Good luck. Once you're done, let's move on to the next section. Alright, let's get back to our Nessus and Nmap results and put together an attack plan. Take some notes, devise a plan, and see how we're going to break into the target in more than one way. So let me go back to the filter, and I'm going to again filter by exploit available, just to make sure that I'm looking at vulnerabilities that I know have an available exploit. And here they are. If we start with the first one, the SSL multiple issues, we know that there are a couple. We've seen one of them already. Let's double check the first one. And again, similar to the second, this is only exploitable by core impact. For now, we're going to believe what the Nessus report says, and we're going to assume this is correct information, and we're going to leave these vulnerabilities alone because we don't have the core impact tool. So let's go back to the vulnerabilities, and I'm going to look at the second one, the NFS exported share. So this is a shared drive on Linux that is being exposed. It doesn't look like it gives us remote shell, but let's double check and read the details anyway. So here we are. It says there's a share that if you can mount it remotely, you'll be able to read its content, and that you are actually able to connect to it remotely. Alright, let's leave this be. Let's move on to the third one. Unreal IRC-D backdoor detection. Now this tells me that there is a remote server that is running and that is vulnerable and exploitable with Metasploit. And notice that Nessus gives you the exact name that you can find in Metasploit. The exploit name, that is. So keep that in mind. Now let me go back to the Nmap results. As a matter of fact, you know what? Let me note down what I've been telling you. So let's go ahead and write down what we're just discussing. I'm going to copy that, the Unreal backdoor detection, and I'm going to put it in my notepad. And next to it, I'm going to write Metasploit, just to remind myself that this is exploitable by Metasploit. Now let me go back to the Nmap results. I'll start from the top. The first thing that we see is an FTP server running on port 21 that is called VSFTPD. So I'm going to copy that and add it to my list of notes. I did mention very briefly in previous videos something called vulnerability mapping. And vulnerability mapping is when you try and find vulnerabilities that affect a very specific version of a software and you map it to that software so you can later try and exploit it. And this is what I'm going to be doing now. And it can be as simple as searching for exploit and the name and the version of the server affected. So if we look at the results here, the second one you can see is in a website called ExploitDB. And the people behind this website are the same people that are behind Metasploit. This is basically a database of exploits available that you can find online for free. And as soon as you open this exploit, you'll notice straight away that it says that this file is part of the Metasploit framework. In other words, this exploit code that you see here is already integrated with Metasploit. Why is this so important to us? Because before there was Metasploit, what we had to do is go and look around on the internet and find exploits that people have written so that we can take and customize to our need. So if you would have found an exploit lying around on the internet, chances are that it wouldn't have worked. You would need to understand the code behind the exploit and you would need to be able to change bits and pieces of the code. For example, the targeted IP address, what kind of action you want your exploit to do. Do you want it to create a remote shell? Do you want it to add a user so you can log in? What is it that you want it to do? And a lot of other parameters that could have broken the exploit if not successfully configured. So if you couldn't read exploit code or you didn't know how to code your own exploit, you wouldn't have been able to use exploits that were lying around on the internet. And what Metasploit did is that it came and collected most of these exploits and put them in a unified framework and made it very easy for us to customize these exploits. In other words, instead of me digging and sifting through the code of the exploit to be able to manually change the IP address of the target and manually change the port number and so on, I can do that through Metasploit. And Metasploit will go ahead and change that on my behalf so that I can just run the exploit and it would be as easy as 1, 2, 3. And this is here the name of the exploit that I will be able to find in Metasploit. So I'm going to go ahead and keep another note saying that this is the name of the exploit and that it is also available in Metasploit. Let me go back to my Nmap results. I'll scroll down. And I told you already, keep note of this, the Samba SMBD version 3.0.20. So just keep that in your notes and let's move on to another one, which is the Pro FTPD version 1.3.1. I'm going to do the same thing that I did with the VSFTPD. I'm going to look for an exploit for this. Now, Nessus doesn't mention anything about it, so I'm just going to do my own research. And this is the process of trying to find an exploit to your vulnerability. Now, the first thing that I see is a Pro FTPD IAC version 1.3.x. X means it could be any number. It could be 0.1, 0.2, 0.9, whatever it is. But when I open the exploit, it does not look like it's an exploit for Metasploit. So unless you knew how to read this code and you knew how to tailor or edit this code, chances are it's not going to work. So I'm going to leave this for now and I'm going to try and find something that I can use through Metasploit. So let me try Pro FTPD 131 Metasploit and see if I can find anything. By having a quick look, it doesn't look like there is much going on in that regards. I can see an exploit that affects version 1.3.3, but that's not the version of my server that I'm trying to target. So this isn't going to work. Alright, let me go back now and pick a target. I'm going to go with the VSFTPD version 2.3.4 because with a little bit of research, I know that this is a vulnerable target. I know that there is an exploit in Metasploit that will allow me to take advantage of this weakness. To look for this exploit, in Metasploit, all I have to do is type search and VSFTPD. The search functionality in Metasploit accepts any keyword. So you can type VSFTPD, you can type Windows, you can type a CVE number, you can type whatever it is that you want, and Metasploit will go and search for that and present you with any results that it finds. In our case, there is only one exploit that affects VSFTPD, and it looks like it's exactly what we want. The VSFTPD version 2.3.4 backdoor command execution. So now I need to tell Metasploit that I want to use this exploit, and it's as easy as saying use and the path or the name to the exploit. Now here you'll notice that the words are popping up very quickly. That's not because I'm a super fast typer. No, that's because I'm using the autocomplete functionality, which you can do using the tab. So just type a few letters, for example EXP, and type tab, and Metasploit will autocomplete it for you. Once you hit enter, you'll see that the prompt has changed. Notice that from MSF5, it changed to MSF5 exploit, and in the red color, the name of the exploit, meaning now you're operating from within the code of the exploit. Let me try and clear the screen. Oops, that doesn't look like it's worked. Sorry, I'm used to the Kali Linux version, and that usually works. Never mind, let's carry on anyway. Now what I want to do is I want to set up the options of this exploit. Remember what I told you? We would have in the past needed to do this manually, set up the IP address that we're targeting, set up the port number that we're targeting, and other parameters. Now in Metasploit, we can do this from within the framework. To be able to see what are the options that I need to configure, all I have to do is type options and hit enter. And look at these columns here. The column that says required yes means that I need to fill these gaps. So this one is already filled. This says port 21, and let me go and double check that this is actually running on port 21. Yes, it is. This is according to Nmap. So the only missing piece is the R hosts. To set the R hosts, all I need to do is type set R host or R hosts and the IP address of my target. Now let me double check that it is set. I'll type options again, and here we go. You can see the IP address set next to the R hosts. Now in Metasploit, we do have the option to try and check if the vulnerability is actually exploitable or not before we run the full exploit. And this is useful to make sure that the service we're trying to break into is actually 100% exploitable before we run the exploit and risk crashing the service. Because running an exploit, unfortunately, sometimes could end up crashing a service, so we have to be very careful with that. Now, in this module, it doesn't look like check is supported. There is no check option, so I'm gonna have to just go ahead and run the exploit and hope for the best. So I'll type run and hit enter. And it looks like the exploit is running, and the second you start seeing these green plus signs, this is usually a very good sign. And here we go. We have a command shell session open. Now it doesn't look like much is happening, but that's absolutely fine. The command shell is open, but you just do not see a prompt. You can still type commands and you will get the output. So let's do the ID command that we already saw in previous videos. I type ID, and it tells me that I managed to break in as the user root, which is great news. I have the ultimate power over the system now. So now I have a remote command shell and I have access as the root user. Let me try to run the other command that we saw, which is the ls, that lists the contents of the directory. And here we go. We have the contents of the directory listed. Now, similar to what we saw with Telnet, if I want to exit this prompt, all I have to do is type exit and I'll go back to the Metasploit prompt. To get out of the configuration of this particular exploit and go back to the main menu, all I have to do is type back, hit enter, and I'm back to the original prompt. Perfect. So this is the first exploit that through it we managed to break into the target system and compromise it as the root user. Let me have a look at another exploit. So we saw that there's a service called ProFTPD version 1.3.1 running on port 2121. However, when we did some research, we weren't lucky. We didn't find any exploits, at least for Metasploit, that we can use. But let me try again. Let me search inside Metasploit this time and see if I can find anything. So I'll do search ProFTPD. And I can see a number of exploits here from the year 2006 all the way to the year 2015 that affect different versions of ProFTPD. Unfortunately, none of those affects the exact version that is running on my target machine. And this is very important to note because these exploits usually work for very specific versions on very specific operating systems. So even if you find a service that is vulnerable and exploitable on a Linux machine, if you find that exact same service with the exact same version on a Windows machine, that does not necessarily mean that it's exploitable. Chances are it will be, of course, but not always. So let me demonstrate this. So I'm just going to pick a random one. Let me go with the ProFTPD 133C backdoor. And I'll use the same procedure. I'll set the rhosts, which is the IP address of my target. Let me fix the IP address. And I'll run the exploit. Now, as you can see here, the exploit ran, but the output returned saying that no session was created. So Metasploit executed the exploit. It ran it, it sent it towards the target machine, but we did not receive a command shell. Clearly because we're sending the wrong exploit to the wrong version. But let me double check something, because if I'm not mistaken, the remote port needs to be changed. Yes, so the R port here is 21. In our case, however, the R port is 2121. This is the remote port that the ProFTPD is running on the target machine. So let me set the R port to 2121. And let me see if the check here works, by the way. It's not supported, that's fine. Let me try to run the exploit again. We'll give it a second. Now notice the difference in the output here. If you're paying close attention, you'll see that there is one extra line as compared to the previous output. You see where the red minus sign is? That says not backdoored. This is because now we managed to target the correct IP address. Metasploit was intelligent enough to detect that this is the correct service running, a ProFTPD service running, but it is not backdoored. There is no backdoor affecting the service that allows us to break into it. So there you have it. Two examples. One that worked successfully because according to our research, we were able to find the correct information and we were able to find the exploit in Metasploit, run it against the target and get a remote shell. And the other one, we were not able to find an exploit and we were not able to break into the system. So here's your mission for this section. Actually, you have two missions. The first one, break into the system through the Unreal IRC service. That should be easy enough. Nessus tells you exactly what framework you need to use and the name of the exploit that you need to find to use. The second one is a little bit more challenging. I told you to take note of the Samba service. Now Nessus did not report this to be vulnerable. However, it is. So do a little bit of search, see if you can find any vulnerability affecting that particular version and see if you can exploit it using Metasploit. Good luck, and when you're done, let's move on to the next video. With this, we reach the end of our Hacking for Beginners course. I would like to congratulate you on completing this course. You've come a very long way since we first began. We covered a lot of ground in this course, although it was a short course, but make no mistake, we have covered a lot of ground. And I hope by now you have gained a solid foundation and a very good understanding of all these concepts that we discussed in such a way that you can now start building on top of these. We talked about what the internet is and how does it work. What are IP addresses? What is the difference between public IP addresses, private IP addresses, and why they are needed? We talked about network address translation and how it connects private IP addresses to the internet. We also explained what DNS is and how it's an integral part of the internet. We talked about what servers are, what services are that run on these servers, and how all this comes together to create the internet that we know of. And we said that for you to be able to hack remotely, you need 4 different components: the IP address, an exposed remote service running on the IP address, a vulnerability in the service, and an exploit. Then we proceeded to explain what services and ports are, and how each service would have a different port number. For example, mail would have port 25, and web would have port 80. But that's not just it. We said that the web does not have a port number only assigned to it. It also has a protocol assigned to the port number. So for example, web would be running on port 80 on TCP, the Transmission Control Protocol. We explained what protocols are, how the Internet Protocol or the IP has the sole purpose of delivery. It cares about the source and the destination only. How the TCP, which works on top of IP, takes care of the correctness of the order of packets, the errors in the packets, and the lost packets. And we explained what the TCP three-way handshake is. We also talked about HTTP, the basis of data communication on the World Wide Web, and how HTTP works in conjunction with TCP and IP. We looked at an HTTP request and we dissected some packets. We looked at the IP packets. We saw the source IP address, the destination IP address, the source port number, the destination port number. We looked at the TCP packets and we saw how the flags are set, the SYN flag, the SYN ACK flag, and the ACK flag. And we saw how the HTTP GET request works. Then we moved on to talk about how you can identify open ports and running services on machines, and how you can do that using port scanning. And then you got introduced to your first hacking tool, Nmap. You learned what a SYN scan is and how does it work, and you did a port scan against hackthisite.org and against the Metasploitable machine on your virtual machine environment. And then we talked about vulnerability scanning, the third step in our hacking methodology. So first we identified the IP address, second we identified the open ports and running services, and then third we identified the vulnerabilities on these services using the Nessus vulnerability scanning tool. We picked 2 vulnerabilities from the Nessus scanning tool, one vulnerability with a weak password and another one with the remote code execution vulnerability. The first one was super easy to exploit. All we needed was a piece of software that helps us connect to the service, and using the password we were able to log in remotely to the target machine. The second one was a little bit more complicated and a little bit more fancy. And for that, we used the Metasploit framework, which has thousands of exploits readily available in it. We picked the exploit that worked for us and we use it to gain remote access over the target machine. So with that, we covered the 4 stages of hacking. We identified the IP address, we identified the exposed running services, we identified the vulnerabilities on these services, and last but definitely not least, we exploited these vulnerabilities to take remote control over our target machine. So there's a lot of ground that you covered, so many different concepts that you learned, and for hanging in there, I would like to say congratulations. Now you might be wondering what's next for me. And to answer this question, I want to take you back to one of the very first slides, the Hackers Academy way of learning. First, you learn and master the foundations. Second, you practice, practice, practice. Third, you share knowledge. And 4, you learn some more. Now that you've learned the foundations, it's time for you to practice a little bit more. Go and redo these exercises. Make sure that you understand each and every single one of your missions, that you've completed your missions. And remember to record your success, because once you submit the report, once you submit all the screenshots and the outputs from your missions, there's a very valuable prize waiting for you. So practice, practice, practice. Hang out on the Hackers Academy forum and share your knowledge. Answer questions that your fellow students have. Share some of the discoveries you made. Maybe you learned a new technique. Maybe you found a new tool. Make sure you share this with your fellow students. And then, once you're very comfortable with all that, it's time for you to learn some more. Go to the Hackers Academy training page. Find out what other courses might interest you. I would suggest one of two courses. If you want to learn more about Linux, we have the Linux for Hackers course. Or if you want to dive more into ethical hacking and penetration testing, we have the Professional Penetration Testing course ready for you. But do note though that the Professional Penetration Testing course is a very challenging course. It's not an easy course. It's 4 or 5 days of continuous hands-on practical learning that teaches you how to become a professional ethical hacker. So pick one of the courses that you find yourself interested in. Get in touch with us, ask us about these courses and how you can enroll in them, and get on your way onto becoming a professional expert ethical hacker. I look forward to hearing soon from you, and until then, happy hacking.